Héctor Martinez Guajardo holds a master's degree in computer science and is currently pursuing a PhD in the same field. His primary research interests focus on fuzzy logic systems and bio-inspired optimization algorithms, with an emphasis on integrated Type 1 and Type 2 fuzzy logic into nature-inspired meta-heuristics. He has authored 3 research book chapters. In addition to his publications, he has actively participated in international conferences, which reflects his ongoing commitment to the advancement of hybrid intelligence systems. Without further introduction, Héctor Martinez Guajardo.
Hi, good afternoon. Okay, well, let's continue. We have here the fuzzy Dragonfly algorithm for solving global optimization problems. Authors, we have the Dr. Febrier Valdez and myself. So, let's continue. We got the outline. We got the introduction, justification, the Dragonfly algorithm, the biological inspiration, proposed model, the results, and the conclusions. Well, as an introduction, we have 2 paths. The first one is the genetics algorithms. And as you can read here, those are structured sequences of steps designed to solve specific problems. On the other hand, we have the bio-inspired algorithms, which these ones, due to the observation and the investigation, they see something very special, the behavior. The bio-inspired algorithms were implemented to the behavior, and these are one of the examples that we have here: the particle sum optimization, the Firefly algorithm, and the Dragonfly. As a justification, we have, we take the decision of the Dragonfly because this can solve complex optimization challenges. And we aim to enhance the performance of the standard Dragonfly by integrating Type 1 and Type 2 fuzzy logic to the parameter control. We can see here one of the strengths of the Dragonfly algorithm, especially 5: the separation, alignment, cohesion, attraction, and distraction. So the main idea of this one is to create an hybridization so we can develop another bigger and robust application. So in this one, we can select the exploration and exploitation, which is one of the strengths of the Dragonfly algorithm. Here we can see the mathematical specification of the 5 biological inspiration of the Dragonfly. We can see the separation, which is the individuals avoid static collisions with the neighbors. We can see the alignment, which is individual velocity matched with neighbor individuals. We can see the cohesion, individual tendency toward the center of the hair, and you can see some images right here so you can have an idea. Well, the Dragonfly flowchart. We will initialize the Dragonfly population. After that, if the T is less than the max iteration, we will calculate the Dragonfly's fitness, update the food flow. We will update the values, calculate them, and then update the neighborhood radius. And here is where the magic happens. We will apply type 1 fuzzy logic or type 2, depending what we are implementing on this one. If the Dragonfly neighborhood is less or equal to 1, we will update the velocity of the vector and the position of the vector. And we will review the new positions based on the limits of the variables. All this happens until T will be max to max iteration. Well, this is the type 1 fuzzy configuration for beta parameter, one of the main parameters of the Dragonfly algorithm. And you can see that we select iteration as an input with 3 membership functions, and beta as an output with 3 membership functions. We select 3 base systems. You can see if iteration is low, then beta is high. If iteration is medium, then beta is medium. And if iteration is high, then beta is high. Well, Now we implement the type 1 function results. All these results were with 1,000 dimensions of Dragonfly, and we compare the Dragonfly baseline against the Dragonfly with type 1. You can see the 10 functions here are 10 benchmark functions. And you can see the mean and the standard deviation of the baseline and the Dragonfly applying type 1. After that, we continue with experiments, but now applying type 2 physics. And you can see three of the most that are used right now in the experimentation or in the literature. We can see the Gaussian, the triangular, and the trapezoidal. On this part, you can see all the parameters that we use and the values, but all of them use a 3 rule-based system, same as the type 1 physiologic. Here are the comparisons of 1,000 dimensions and the Dragonfly baseline, the Dragonfly with type 1, and the Dragonfly with Gaussian functions results. Then we have the type 2 triangular functions. Same one, we did the comparison with the Dragonfly type 1 and the Dragonfly type 2, but applying the triangular functions. And last, we have the same kind of experiments comparing Dragonfly type 1 and Dragonfly type 2, but with trapezoidal membership functions. Now, here we have the comparison results of the 1,000 dimensions of Dragonfly, type 2 Gaussian, type 2 with triangular, and type 2 with trapezoidal functions. You can see the mean and the standard deviation of each one of them. And we have here the conclusions. So the analysis experimental results demonstrates that integrating type 2 physiologic into the Dragonfly impacts in the optimization performance. We have here one of the benchmark functions which got most impact on the Gaussian especially. And in this one, the F3, F4, F5, F7, and F10, the triangular and trapezoidal functions exhibit higher means and deviations, indicating less stability compared to Gaussian functions. And as a future work, I want to bring your attention to this too. How we can implement this type 2 work to a medical application. Well, we can select data sets to, medical imaging. Oh, here it is. The Dragonfly for optimizing classifiers in diabetes detection, cardiovascular disease, risk assessment, or cancer classification, using, obviously, the data sets of those. I think it's that.